Bismillahirrahmanirrahim and Assalamu alaikum to all of you guys. I hope you all are good. So this is Noor with the fourth video about the content of geography. So in this lecture we are going to talk about the earth as a planet, its shape and its size. So it's gonna be very interesting lecture and very important lecture in terms we will talk about the summer solstice, the winter solstice, the equinox, and many more. So stay tuned. So very firstly, we will talk about the Earth. So Earth is the only planet to be named in English because there is no other any planet which is named in English. So it has some specifications. The word Earth is Old English word for land, and Earth belongs to the Milky Way galaxy because there are many galaxies, but the galaxy from which the Earth belongs, that is Milky Way galaxy. And the very important point is that the Earth is the only planet to sustain life, because we see many other planets which are hottest, which are coldest, which are green planet, and many more. They have qualities, but they none of the other planets have some qualities, have some characteristics that can, in which the survival is possible. So the Earth is the only planet that can sustain life. And now we will talk about the shape of the Earth. What is the shape of the Earth? So firstly, we are going to know the term in which we study the shape and size of the Earth. That is called as geodesy. So geodesy is a term in which in which we study the shape and the size of Earth. And before 500 BC, people used to thought that Earth was flat, but thanks to scientists, that they showed us many experimental experiments that proved that Earth was not flat; it was spherical. But after more experimentations, it was proved that Earth was neither flat nor spherical. It was a compressed spheroid. Now, what is compressed spheroid? It means that the true shape of the Earth is called as an oblate spheroid, because oblate spheroid, because at both ends of the Earth, the Earth is slightly tilted, and that tilted one appearance is known as oblate. So that's why the Earth is called as oblate spheroid. So now let's show the diagram of the Earth. So here you can see the diagram of the Earth and the 2 points indicating that it is tilted, and due to its tilt, that is called as oblate spheroid. So Earth is neither flat nor spheroid, it is oblate spheroid, which means it is slightly tilted from its ends. And now, Earth's formation and evolution. So mostly scientists believe that the Earth also formed when the sun and the other planets were formed. But so let's see that is it true or wrong. Is it true or false? So as you all know, that what is solar nebula? Solar nebula, it is roughly a cloud of gas and dust. A cloud of gas and dust from which the solar system came out. So when the solar nebula collapsed because of its gravity, it is a rotating cloud, so it will spun faster. It spun faster and flattened it into a disk. So most of the material was moved to the center, and that material causes to form sun, and the other particles within the disk collided and stuck together to form larger ever bodies, including other planets. So that's how the Earth was formed. That's how the Earth evoluted. So the age of the Earth is approximately 4.54 billion years. The earliest undisputed evidence of life on Earth dates from at least 3.5 billion years ago. It means that Earth was formed approximately 4.5 billion years ago, and the life starts to exist approximately 3.5 billion years ago. And let's talk about water and life on Earth. So water covers 70% of Earth's surface, but it is a very bitter truth that it has only 3% of the total quantity of water it is fresh, and only a fraction of 1% supports all life on earth. So you can see that how depressive it is. So now study the earth as a planet. What is earth as a planet? So as a planet, the earth has two main movements. The one is rotation and the other one is revolution. Rotation, it rotates on its own axis, and revolution is in a body which rotate around any other planet. So the when earth rotates about its own axis, that is called as rotation, and when the earth rotates around the sun, it is called as revolution. So firstly we will talk about the rotation. The earth rotates around its axis every 24 hours. So when the earth rotates around its axis every 24 hours, what do it do? It causes day and night formation. So when the earth will rotate, the sun's where the sun's light will reach, it will cause day there, and where the place where the sun's rays will not reach, there will be dark area called as night. So as you can see the earth's rotation day and night. So in this diagram, let's see that the one part is night and the other part is day. So the lighter part here, the lighter part at which the sunlight directly falls, so that causes day, and that area in which the sunlight don't fall directly, so here the sun never rises, so that causes night. So this rotation causes day and night, as the sun's light only illuminates part of the earth's surface while the other parts are dark. So thanks to rotation, that no particular part of the earth is too hot or too cold, which allows the existence of life on earth. So now we will talk about the earth's revolution. So as a planet, the earth orbits around the sun. That's known as revolution. So it takes the earth around 365 days and 6 hours to complete a full revolution around the sun. The earth's revolution causes years and leap years, seasons, and a changing length of day and night. So it takes 365 days and 6 hours for the earth to complete a full revolution around the sun. So we have established the length of years in 365 days. But the one thing we have to remember is that every 4 years we sum up the extra 6 hours, obtaining an extra day. So this is called a leap year, as it has a length of 366 days. So what's the relation of Earth's revolution with seasons? Let's see that depending on the position of the Earth in its orbit around the sun, some parts of its surface are closest to the star and some are farthest. The sun's rays reach intertropical regions at a direct angle, and that's why the intertropical regions are too much hot than the poles, because the sun's rays reach the poles at much smaller angles. That's why the polar regions are considerably colder than the intertropical regions. Because of that, different parts of the Earth's surface receive varying amounts of solar energy, and that causes the seasons like spring, summer, autumn, and winter. Here lies the very important point of this lecture, and it is that the summer solstice and winter solstice. We will talk about the solstice and equinox in the next slide, but here I'm going to tell you that. So here we will talk about that the June 21st is considered the longest day of the year, and 22nd December it is considered as the longest night of the year. And let's talk about the equinox, spring and autumn, the March 21 and September 23. It is the day or night in which the time period of both the nights and days are equal. So let's study about the solstice. So when the earth is at its farthest point in its orbit from the sun, it is at its farthest point, it is called as solstice, and it is when the sun's rays are vertical at the tropics. Let's see how. Summer solstice takes place on the 21st of June. The sun's rays are vertical at the Tropic of Cancer. And winter solstice takes place on the 21st of December. The sun's rays are vertical at the Tropic of Capricorn. So let's see what are the Tropic of Cancer and what are the Tropic of Capricorn. So as you can see in this diagram, above the equator there it is Tropic of Cancer. So summer solstice will take place when the sun's rays will be vertical at it. So summer solstice will takes place at that time, and below the equator it is Tropic of Capricorn. So winter solstice will take place when the sun's rays will be vertical at the Tropic of Capricorn. So earlier we talked about the solstice. So now let's move to equinox. So when the earth is on its closest point to the earth, we call it as equinox. The sun's rays are vertical at the equator. Spring equinox takes place on the 21st March, and the autumn equinox takes place on 23rd of September. So, and the sun's rays reach intertropical region at a direct angle for most of the year. So as we have talked earlier, that sun's rays reach intertropical regions at a direct angle, so that's why these intertropical regions are much hotter relatively to polar regions. And the tilt of the Earth's axis of rotation plus the position of the Earth on its orbit determines the existence of climatic zones. Climatic zones, tropics, temperate zones, and polar regions. So let's see these zones. So as you can see in this diagram that here it is written 0-degree equator. So it is the equator line, and above the equator line and below the equator line, this is the red region that is called as tropical region. These both are called as intertropical regions. So at intertropical regions, the sun's rays falls at a direct angle. So these are much hotter relatively to the polar regions. And above tropical regions, there are temperate zones colored as green. And last one is polar zone. And polar zones, at polar zones, the sun's rays falls at much smaller angle. So that's why these are considered as very, very, very cold areas. Like we can say the Antarctica. It is very colder area. So different areas lies here. Now the tropical region, the tropics are located between the Tropic of Cancer and the Tropic of Capricorn, and they receive the greatest amount of solar energy through the year, which causes the high temperatures throughout the year and little difference between the seasons. So as you can see here, between the line that is equator and above the equator there is tropics. Tropic of Cancer, then here below it is Tropic of Capricorn. Then temperate zones, these are temperate zones, and then the frigid zones. We firstly talked about the tropics. The tropics are placed between the Tropic of Cancer and between the Tropic of Capricorn. And when we will talk about the temperate zones, so temperate zones are located between the tropics and the polar circles. As you can see here, that temperate zone above the Tropic of Cancer, above the subtropics, temperate zones are located between the frigid zone and the tropical areas. So we have collectively 2 temperate zones, and the number of daylight hours gradually falls between the summer and the winter solstices, and these zones have 4 seasons: spring, summer, autumn, and winter. And the last one is polar regions. The polar regions are located between the polar circles and the poles. And they receive little solar energy, so the temperature of these polar areas are very low, and there are big differences between the length of day and night. Very, very big differences because of the rotation and revolution differences. And the sun is visible in the sky only for 6 months of the year in each pole in the summer, and anyway even then the sun provides very little heat because its rays hit the polar regions at a low angle. So the areas of the polar regions are very cold relatively to the tropical regions or the subtropical or temperate zones. So that's what we have talked about this lecture. I hope you all have got it. So we'll meet in the next lecture. Till then, take care. Allah Hafiz.